All right, functions from a calculus perspective. So this is going to be drawing a lot of your Algebra 2 previous knowledge. We're about a week ahead of where I was last year. So that's solid because I go through and I look at the lesson plans, which means the places where people really struggled last year, I put an extra day. So that way you'll be highly successful. You have 2 more tests. In Chapter 1, before the end of the semester, the Chapter 5 tests will be graded as soon as everyone's done taking them, which is tomorrow, but I'll probably grade most of them today. Let's see what else needs to be known. I don't know. Friday, Alex is due what? Chapter 5. Yeah.
Wait, we even take home quiz?
Surprise! I was gonna wait till you guys saw that the day of. Yeah. Oh, how nice. How nice of me. Oh, you're welcome. Oh my gosh. Look at your lesson plan. It's on there. These questions can all be answered by looking at your paper and reading. Okay, team. Fun fact, did you know I'd uploaded the solutions to the Chapter 5 homework before the test? Okay. All right, so enough of that. Chapter 1, functions. So a little review from pre-algebra, algebra 1. So real numbers are ones that don't have an I. That means they're not imaginary. If they're not imaginary, it means they're real. So real numbers can be broken down into 2 subsets, either irrational or rational. Irrational do not terminate. The decimals go on forever. You cannot write them as a ratio of 2 integers, but rationals, literally you can write as a ratio of 2 integers. So although 0.33333 repeating forever does not terminate, you can write it as 1 over 3. So irrational are like square root 3. A lot of the roots, honestly, if it's not one of these square numbers, 4, 9, 16, 25, 36, and you're taking the square root, it's probably going to be irrational. Okay, so let's say, so irrational can be written as a ratio of 2 numbers, but more specifically, there's a smaller subset in them, which are also integers. So there's no decimal places, either positive or negative. So it's like those Russian babushka dolls, right? You know, inside each other. Yep. Cool. What else? So all integers, so the z is just integers. All integers are rational, but not all rational are integers. And then some of the integers, more specifically, are whole numbers. It's 0 and all the positive numbers that are integers are also whole numbers. And then more specifically, natural numbers are what my nephew is learning how to count with. So when you learn how to count, you start with 1, and then you go 2, 3, 4, 5. So if a natural number is also a whole number, it's also an integer, it's also rational, it's also real, but the most specific category I can say is natural number.
So is that 1 through 9?
So it's 1 through like infinity. 101 is still a natural number because it's a positive integer. Because 0 is not technically positive. 0 is only whole, it's not natural. So, cool.
How could a whole number not be natural?
0 is the only whole number that's not natural. Yep. So wholes is natural plus 0. Integers are is 0 and then the plus or minus of all the natural. Okay, so why am I reviewing this? So I'm going to show you these fancy little letters. It's also a good idea to somewhat expose you to what you'll see in college. I don't want to set you up for failure by spoon feeding you these little practice tests that are very much like the real test and giving you these printed note packets and screencasts. That's not what college is at all. As my tutoring client yesterday reminded me what real math is like. Ooh, I'm just going to try to warn you guys, all right? So if you're seniors, I'm just going to really try to show you. So this next part, the set builder notation uses the properties of the numbers in the set to define the set. Okay, so the reason I'm showing you this is if you go take pre-calculus in college, you'll have to know this. They expect you to know this and they go through it. And I want you to see I want you to somewhat see it. You don't have to really be familiar with it, but just know math is a language. You kind of have to know how to speak it. So have you guys ever seen one of those fancy smancy like science papers with all this like math and writing? Have you like looked at that? No. That's cool. Lame. Okay, so imagine that you open up like a thesis from a doctoral PhD student in astrophysics. You would look at it and it literally is a different language. You will not recognize much of the math at all. You're like, what the hell is this? So the secret to unlocking it is you just have to understand what each part means. Like, granted, you have to know the physics behind it, but you already know what this R with the little special line means. It means all real numbers. This little epsilon looking character, it means, okay, it's a type of number. It means is an element of. So if I say, like, x is an element in all real numbers. Oh, that makes sense. So my number, x, is just going to be a number that's going to be an all real number. That's going to be in my all real number set. Meaning, anything with imaginary I would not be in that set. All right, so I'm going to try to, like, show you how to do this. It's one way to describe, like, a set of numbers. I'm not going to test you heavily on it later, but I want to show you it. Because if you do take pre-calculus in college, regardless if it's community college, university, whatever, you have to know this. Okay, so there's different things to look at. So this left one, this is the model of how we'll do it at the bottom. So this first part is the name of the group. So guess what? I'm normally just going to be using X's. That's going to be the name of my group, is just X. This middle is what's inside the group. So what is included? What's my boundaries? And at the end is all the numbers in the group are what kind? Oh, here, Z are integers. If they all were Q, that would stand for rational. How do I know this? Top of your page with all the letters.
Are we going to be given like that on the test? Like the letters and names?
I mean, I will give you a practice quiz and then I can address that. Yep. So this is mostly like show you, maybe I'll have a problem or two on it, but that's not the most important thing. Interval notation, that is God. That's the next page. That's probably the most important thing of this chapter because we're going to use it in all the rest of the chapters. Okay, so I want a general outline. So I'm going to say X such that, and then I have to have like my boundaries, right? That's what I'm going to be putting here is like where are my boundaries. And then I'm going to say X is in the set of something. So I'm kind of making a template, if you will. Okay, what are my boundaries? What's X is between what two numbers? Shane.
X is greater than or equal to 2. X is less than or equal to 7.
Yeah, so I'm just going to write compound inequality. 2 is less than or equal to X, which is less than or equal to 7. And then all of these numbers are a part of which set? What's the most specific? Natural. That's the most specific we can be. Natural numbers. Yeah. Try to draw it like with the fancy like up above. So I'll give you a couple of questions about this. I forget if I put it on your quiz or test. If so, it'll be like one question. I want to expose you to it because this part is used in your next math class. This part right here will be used in your next math class. I want you to know what this means. So that E just means is an element of. Is an element in the set of, so I say X is an element in the set of natural numbers. Perfect. So the only X's I can plug back in are natural numbers. Which ones? The ones between 2 and 7. That describes my set. Perfect. All right, let's do B. So X is greater than negative 17. Okay, so I'm going to start with my template, X, such that, let's see, what are my bounds? What numbers am I between? Yes. Exactly. So I can just say X is greater than negative 17. Oh, yeah. Greater than negative 17 means it goes to positive infinity. Okay, and then x is an element in the set of, so I want you, so what should I put here? Integers? So I want you guys to think of a number greater than negative 17. Ready? Go. Okay. Now, who wants to give me an idea? Who wants to tell me a number? Yes.
Negative 16.
All right. So negative 16. Perfect. Guess what? This is an integer. That works. So we see it can't be natural, or can it? Shane?
It can be 1 because 1 is still greater than negative.
4 is greater, so that's a natural number. But I want the most specific I can be. How about like 0.5? Is 0.5 greater than negative 17? Ah, it is. And wait, this is rational.
It should just be q.
But what about pi? Is pi greater than negative 17?
Yeah.
So what's the most general one I can put?
All real numbers.
All real numbers. All real numbers.
But it's not all real numbers.
It is.
Negative 18.
No, but the bounds are x has to be greater than negative 17, but the x values I plug in, it can be a set of anything that's an all real number as long as it's greater than negative 17. I could plug in pi. That's true. That would be part of my set. So my set is literally the numbers. Who's calling me? That's my sister. Heard you're in lockdown 2 hours ago. All right. So x is greater than negative 17. So I want all the numbers that are greater than negative 17. Well, all the numbers I could come up with, the most specific thing I could call them are all real. Because I came up with a rational number that's greater than negative 17. I came up with an irrational. So the most general I can be, the most specific I can be is all real numbers. Okay, I want you to try C. See if you can do it yourself. Try out C. Try out C. So I see I'm between negative 10 and 6, and all of these numbers, they're all our real numbers. They're all rational. They're all integers. Are they all whole? No. So the most specific I can be is integers. So the most specific I can be is Z. Okay, so let me break it down because this is a lot to look at. It's like a whole other language. So I have a set of numbers. I'm going to call it X. The boundary is they have to be between negative 10 and 6, and the only X values that are going to be a part of it is going to be integers. So as long as I pick an integer that's between negative 10 and 6, I can plug it in, and that's part of my set. Versus the other one, let me come up here a little bit. All right, versus the other one, I'm going to have a group of numbers. I'm going to call it X. And the thing is, all the values in my little group, they're all going to be greater than negative 17. So looking in my bowl, it's kind of like I have a bowl of Halloween candy. You don't know what's in here, but I'll describe some of the stuff, right? So I'm like, okay, they're greater than negative 17. So maybe Maya's like, well, do you have like a Snickers in there, right? Is pi greater than negative 17? Like, yep. So I have an irrational, I have a rational, I have a whole number. I have a natural number, so I have this whole mix of numbers in here, and the most specific I can be that I can call it is all real numbers, because all of them, like not all of them are natural, not all of them are integers, not all of them are whole or even rational, but I have to have the most specific name I can call my group of numbers without excluding any of the answers. So I can call it all real numbers because I know at their minimum, all of them are at least all real. At least all of them are real. All right, and lastly, I give you a little tricky trick. Multiples of 3.
Just be x, negative infinity over 3 is less than or equal to x.
No, what is the x?
Multiples of 3.
Isn't it going to be x plus or minus 3?
So I'm just multiplying it by 3. I'm doing multiples of 3.
Wait,
So
why'd you
Why do you
write-
put n?
here this n is whatever multiple I want. If I want the 5th multiple, 10th multiple,
Would be integers because you could plug in negative.
yes. So it'd be integers because I could put in, let's think about all the multiples of 3. 0, 3, 6, 9, 12, 15, but also negative 3, negative 6, negative 9. They all are integers. Okay,
But couldn't you also multiply the fractions or like?
so multiples of 3. So n is, so I'm multiplying by, it's like integer multiples. So because multiples of 3, because 3 is an integer and I want a multiple of it, so you multiply by 1, multiply by 2, multiply by 3.
But like you could divide 3 by like a fraction and then get.
But it has to be multiples of 3. It has to be like 3 or 6 or 9. It has to be, it can't be like half of a multiple. It's kind of like, if I'm gonna give you an M&M, like how rude would it be if I give you like half an M&M or something, right? Like no, it has to be whole M&Ms. Cool. You going okay? Perfect. All right. On a side note, in case you guys weren't aware, the study hall is now closed the period before lunch. So don't schedule your tests during then. Cool. Okay. So don't want to spend too much time on this. I want to go over the intervals. So bounded intervals literally have bounds. They have a beginning and an end point. So the way we're going to figure this out is we're going to draw a line graph. Yes?
Really quick, did you say the study hall is closed for today or tomorrow?
The study hall is closed the period before lunch. The rest of the year. That's what I emailed you. The period before lunch. Because she switched over. Because now she's open during lunch.
Anytime you have a study hall before lunch.
So on Mondays, G. Tuesdays, G. Wednesday, E. Thursday, F are no longer open for study hall.
I'm supposed to take my test tomorrow.
I emailed you.
Like I said, I could take that.
You are taking a G. You're sitting outside the room.
Oh.
I understand you're tired. Yeah, so you're gonna sit outside like she is doing, and you'll sit there, and then whenever you're done, you'll just hop back in the room. Yeah. It's Miss Bandel. It's by the library. So normally she's closed at lunch, but this just means I don't have to give up my lunch anymore. It's great, because I was doing it like 2 times a week. 2 to 3 times a week. Which is not part of my salary. Okay. That's great. All right, so we're going to draw these in line graph. So you call it? Line graph? Number line. Number line. Draw some number lines. Here we go. So I have A, I have B, I have A, I have B, I have A, I have B. Maybe I should have drawn these for you. Oh well. Okay. So the first one, how would I draw the inequality? A is less than or equal to X, less than or equal to B. So less than or equal to is open or closed circle? Closed. Closed. And if it's bounded, I'm between them. So to make sure we're all like looking up when I do the magic. So my interval notation, you start at the smaller number and the second, and then you go to the bigger one. So I'm going from A to B. Am I including the number A? Am I including the endpoint, the bound? Yeah, it's a closed circle. A closed circle means I include it, so it's a square bracket. Am I including the other endpoint? Yes, so square bracket. So starting 2 seconds ago, the way you write parenthesis versus bracket matter, and I will take off points on the quiz and test if you don't have the right one for interval notation. Very important. All right, so A is less than X, less than B. If it's just less than, it's an open circle. If you're not including it, it's going to be a parenthesis. Can you guys tell the difference between my square bracket and my parenthesis? Yes? Okay. So if you can tell the difference between mine, I should be able to tell the difference between yours. Please make it clear. Square bracket versus parenthesis.
I'm taking her to the room next to the dean so she can see quietly into the white.
Oh, okay. Thanks. Yeah. Yes.
Can you explain again why we're using different symbols?
So a bracket means like closed circle versus a parenthesis means open.
Oh.
So a bracket includes your bounds, an open circle excludes them. All right. So try the next two. Try the next two. Give about 10 seconds. Draw them out. See if you can get it. All right. So A is or equal to, so I have to draw a closed circle above it. B is just less than. So I have to include the A, the left side, but not the B. So I have a square bracket around A, but a parenthesis around B. But this is not the first time you saw it. Remember how we were dealing with an interval, right? Interval from 0 to 2 pi. We included 0, but not 2 pi. Surprise, introduced you to it there. This is very important. You have to understand this. It's going to be very hard to be highly successful in this class and in your future classes if you don't understand interval notation. We're going to be using it for domain and range. Anytime we're talking about a function, I'm going to say, what are the x values for the function? What is the domain? And you have to write in interval notation. I'll say, what are the range? What are the y values? And you have to write it in interval notation. So right now, we're learning about bounded intervals, meaning they have a start and an end point. So we have two actual numbers. Let's finish this side out, and then we'll go to where it's unbounded, where it's just, you have one place and it goes on forever in one direction. That's a little different. Okay, do we have questions over the bounded? Make sure you have your brackets and parentheses correct. You drew them correct? Why don't you guys have some practice drawing? So, okay, let's go to the other side. So unbounded intervals. That means one side goes to infinity. So I guess we can draw these. So I'm going to draw some number lines. Because I'm trying to connect your previous knowledge. Because like you've drawn number lines in pre-algebra, you've done in algebra 1, you did in algebra 2, now we're doing in pre-calculus. I'm not always going to be drawing a number line, but I want you to make that connection until you've had sufficient practice. This is the way we'll do it. A. Okay. So the first one, x is greater than or equal to a. So greater than or equal to means a closed circle, and greater than means going to the right. So I see I'm starting at a, and then I'm going to infinity. So I have to include a, and then I'm going to infinity. But question, am I going to have a parenthesis or a closed bracket for infinity? Yes.
A bracket because it's also equal to.
Let's see, so I have a bracket because I have a, right? X is greater than a, so a is my endpoint. But if you get one of those push pins, can you like, if you had a number line, could you like put a push pin on where infinity is? No. So it's not an actual like point, right? It's not an endpoint specifically, so infinity will always have a parenthesis. So that was a trick question. That was not nice of me. Because it technically doesn't have an end point, right? It goes on forever. And just when you think you found the end, it keeps going. That's like the definition of infinity. It just keeps going forever. Okay. So if x is less than or equal to a, so I have a closed circle and it goes to the left. So I want you to think about how we would write this. So we always go from left to right. From smallest number to biggest number. So I know I'm ending at A, but where am I beginning?
Infinity.
I'm beginning at negative infinity, and infinities always have a parenthesis.
How's it going from negative infinity?
So it's going from the x values, right? So I'm going from negative infinity all the way to A. Whenever we're writing this, we're always going from left to right. So I'm going from negative infinity to A. Just like here, I'm going from A to positive infinity. When you write interval notation, you always go from left to right, left to right. All right, the difference with these last two are open circles, so I don't include A, so I have parentheses around both of them. And then, interesting, think about how you would draw the last one. So I'm going from negative infinity is less than x, which is less than infinity. So, how would I draw this? Just be a line. So you would say you're going from negative infinity to infinity, also known as all real numbers. Zoom out a little bit so you can see both sides. Nope, come on. Come on. Come on, no. I think it's draw board. They want me to upgrade, but I'm not paying that money. Nope. Do we have questions? Let me give you time to finish writing this down. If you are done, I want you to try out A. See if you can figure out how to write part A. How would you write it in interval notation? How would you write it in interval notation? All right, so I think that was enough time for people to write this down. Okay, so I'm just going to draw a number line. I'm not going to do this every time, and I don't recommend you do it every time. But while we're getting used to interval notation, it's kind of helpful because then if you literally can see it. Okay, so I'm going from -2 to 12. All right, so I'm including -2, I'm including 12, and then I'm between them. So I see my endpoints are -2, and I'm going to 12, and I'm including both of the endpoints because it's or equal to. So once again, we will be using this to talk about domain and range. If I have a function, I want the x values. Well, what are the x values? Sometimes it will be all real numbers. It would be negative infinity to infinity. Sometimes, remember when we were graphing sine and cosine? Waves? Yeah, remember that? Waves? What was the range for sine and cosine? It went up to a maximum of -1, and then it went down to a minimum of -1. So if I wanted to talk about the range of sine, I could say the range, it was -1 to 1. That's all, right? All the y values were between -1 and 1. Okay, so it's getting a little ahead of myself, but just really trying to show you where we're going to use this. Let's try out B. Let's try out B. So sometimes drawing a number line will help. Kind of the name of the game today is introducing you to some math nomenclature, just some vocab. Like, how do mathematicians go about this? I don't know. They always write things in a sentence that should probably take a page to write, but it is what it is. Yeah, it is what it is. You know, I make mistakes all the time. Okay. So I have 3 going this way. I have 8 going that way. Uh-oh. I have more than one interval. And when I have 2 and I want to connect them to make them 1, you know, when 2 people marry each other, you witness the union. So when we have 2 intervals, we're going to make it a union. Okay, maybe not. So I have negative infinity to 3, and then U for union, oops, should be bracket 8 to infinity. So this U just means union. All right, so think about what the word union means, like joining together. You know, you always hear about unions being on strike. Well, a union of like steel workers or coal workers or welders. Literally, a union is a band of a bunch of people together to collectively bargain. Well, here, a union is I'm snapping these two intervals together. That's all the U means. Now you can go look at some of these fancy science papers or whatever, and you'll see the U, union. You'll see the epsilon, that just means is a set of. It's literally a language. You just have to learn the language. Okay. Let's do the second part B. X is greater than negative 17. Do we know how we would write this? Or do we need to draw?
Negative 17, comma 8, both with
Negative 17 infinity, both with parentheses. Exactly. And let's make sure we're right. Okay, so here's negative 17. And as long as the variable's on the left side, the inequality shows you which way you're going. Right? Because the inequality literally points to that direction. I don't know if you guys were shown that. Goes that way. So I see, oh, I start at negative 17 and then I go to infinity. And lastly, should be D. X is less than 0. Here's 0, less than goes that way. So I go negative infinity to 0, and they both have parentheses because I'm not including 0, and infinity is never inclusive. Okay, how are we feeling about this? Yeah? I'm going to kind of introduce you to it with like 0 to 2 pi. So let's talk about function just for a hot second. Okay, blah, blah, blah. What is a function? Literally, you only can have one y value for every single x. What do you use to test if something's a function? Vertical line test. Surprise, it's on the next page. Vertical line test. So I have this line. Is this a function?
Yes.
Yeah, because if I look at x, every x only has one y value. Even though they all have the same y, each x only has one y. Now, if I would put like another dot right here, that would give me 2. If I have a different function, even at the very smallest overlap, right here, that still would not pass a vertical line test. Even the very smallest amount. So we'll go through, this will take like, I don't know, a minute or two, and we'll end on this next page. We're just deciding if these are functions or not. So I'll pick some random people. How about Robert A? Is this a function? Why do you know?
Because there's no x that
Each x only has one y. Exactly. Each x has only one y value. So I tried tricking you because I put a 2. Haha, look, it's the same number, but it's in the y. We don't care. Each x. You're only going to have one y value for every single instance of x. Let's go. Ethan, what about this b? Is this a function?
No.
No.
It's 2x, 2x,
Exactly. X repeats. Beautiful. How about Hannah? What about C? Yeah. How do you know? That's beautiful. I like the vocab term. Passes vertical line test. VLT. Not to be confused with its cousin BLT. I think it's funnier watching you guys like squirm with the bad jokes. Tall, do you want to do D? How do we know if it's a function or not? Huh? This is a trick play. This is a hard one. So this is equal to, let's see. I'm gonna switch around. This is mean of me. So I have x over 2 is equal to y squared. If I wanted to get it in terms of y, it would be plus or minus square root of x over 2. So there's a very interesting but important little explanation on the home page of our class that details when do you include plus or minus and when do you not. So like it's a 30-second little read. Just kidding, 10 seconds. Just look it over. It will help you. I would not post it unless I thought it was very, very helpful. Okay, so I just have to graph this. Do you know what a square root function looks like? A square root. You're at the movie theater. Put your arm around someone. And then, yeah, if someone ever does that to you, you can just be like, squared, and like, shoo 'em away. Get it? Because square root and squared. Okay, whatever. I'll stop being funny. I'll make it real lame. Okay, ready? Square root. The positive square root goes like this. What's the negative? Swoop in? No? Okay, that's fine. It's been a long day. Here's the positive root x over 2. Here's the negative root x over 2. Is this pass the vertical line test? No. Does not pass. Fails. Vertical line test. And the last two are relatively chill. All right, let's go tall. What about E? Yes, it passes vertical line test. And lastly, Jesse. No. Fails vertical line test.
Why does it fail?
Because right here, this x value has multiple y values.
Oh, okay.
Okay, so that's a good place to stop. Cool, get ready for some worky work tomorrow.